All right, everybody, so this is the third and final video lesson on symmetry. So you see here that we have 4 examples, and you can see that the question for all of them is it odd, is it even? To remind us, just to kind of set the tone, to summarize our last 2 lessons, which, by the way, if you haven't watched them, go watch them. I kind of included this really quick synopsis of what it means to be odd and what it means to be even. So again, odd functions are functions where the output that's assigned to negative x is the opposite of the output that's assigned to x. And for a function to be even, the output that's assigned to negative x is the same as the output that's assigned to x. I wrote it this way specifically because I wanted to draw your attention to the fact that f of negative x and kind of what happens at negative x is really important for both odd and even. So you'll notice that we're going to use that in our testing as kind of the jumping off point. Okay, so let's look at our first example. Okay, so here it is, f of x equals x squared minus 4. And you might remember, because of course you've watched the other 2 lessons, that this is the function whose graph we were looking at in that first example. So we already know that it's even, right? Spoiler alert. But this is a great example to start with because we kind of know what to expect. Okay, so let's pick a nice color to work this out in. So you'll see that for every example, the first thing I do is I look at f of negative x. What does that mean? It means that everywhere that I see an x in the original function, I'm going to replace it with negative x. So f of negative x is negative x squared minus 4. Of course, you all know if you square the opposite of some number, nothing changes. You get the same as what you would have gotten if you squared the number itself. So negative x squared is just x squared and then minus 4. So I'm sure that you're all with me here in saying, oh, that's just the same as f of x. So sure enough, f of negative x is equal to f of x. So we can say this function is even or symmetric with respect to the y-axis. Let me actually write that here because I want you to make sure that you know that they're the same thing. Symmetric with respect to y-axis. All right, so moving on over to this next example. Okay, so I'm going to scroll over to the side so I have a little bit more room. We're going to take exactly the same approach. So we're going to start with asking ourselves, what's f of negative x? So here we go. Just like we did in the last example, we're going to replace every occurrence of x with negative x. Okay, so 5 times negative x cubed plus 2 times negative x. And then what I hope you all remember is that if you cube the opposite of a number, you get the opposite, right? So this becomes negative 5x cubed. And then plus 2 times negative x is minus 2x. So at this point, different things might happen for different ones of you, but I hope that the thing that immediately pops out is that you're looking at these 2 things, f of x, the original function, and what we just got, f of negative x, and you at least can acknowledge that these are not the same, right? So immediately, the possibility that this function is even has been ruled out. So what I recommend doing at this point is saying, well, okay, well, maybe it's odd. So let's look at negative f of x. Right, so we have negative 5x cubed plus 2x, right? Which, and this will be handy for later, is the same as multiplying 5x cubed plus 2x by negative 1, right? So we're going to distribute that negative 1. So we have negative 5x cubed minus 2x. Okay? Oh, look at that. I'm going to pick a beautiful green color. These are the same. exclamation point, exclamation point, exclamation point. So what we're seeing here is that in fact, f of negative x is the same as negative f of x. So this function is odd. Or, and again, I want you to remember that these are the same thing. That means symmetric about the origin. Okay, so again, it's not terribly important for you to know both of them, but I do want you to know that they are the same thing. Okay, so now let's do this example here. Okay, f of x is equal to 3x squared minus 5x plus 7. So we're going to start the way that we've always started. We're going to look at f of negative x, which means we're going to replace every occurrence of x with negative x. Okay, and you'll see that immediately things start being different, right? So sure enough, if you square negative x, it's just x squared. But if you multiply negative 5 by negative x, you get plus 5x. And then, of course, the 7 didn't have an x in it, so it just stayed plus 7. So again, in like our ominous orange color, we can observe these are not the same. The original function is not the same as f of negative x. So maybe we're still holding out hope that even though it's not even, maybe it's odd. So we can look at negative f of x, right? So that's the same as multiplying f of x by negative 1. This is not looking good, right? You can already sort of see it as I'm kind of fixing it up here. The negative 1's going to distribute, and you have negative 3x squared plus 5x minus 7. So f of negative x and negative f of x aren't the same either. So what that means is this function is neither odd nor even. Okay? And that's totally going to happen. In fact, in most cases, if you were to make a function up off the top of your head, it would probably turn out to be neither odd nor even. But just to kind of cap off this example series, I want to look at this function. It's a rational function, and sometimes the whole question of opposites is a little tricky with that. So we start off the same way, right? So we say f of negative x. We're going to replace every occurrence of x with negative x. Off we go. Okay. So if we could clean this up a little bit, so we have negative 2x up top and negative x plus 5 on the bottom. You can clean it up more if you want. I'll let you kind of play with that on your own. Again, we notice that f of negative x is not the same as our original function. So even is off the table. We're still maybe holding out some hope for odd. So let's look at negative f of x. Okay, so like we've done in all the other examples that it wasn't even, we're going to multiply negative 1 by 2x over x plus 5. And so this is where it becomes kind of handy to remember that multiplying a rational expression by a whole number, it's like multiplying the numerator by that whole number and the denominator by 1. So you see what you get here? On top you get negative 2x. So like, oh, maybe it's going to happen. But on the bottom, there's just 1, so it stays x plus 5. So this is the opposite of f of x. And I think you will all agree with me that it's also not the same as f of negative x. So f of negative x is not the same as f of x. F of negative x is not the opposite of f of x. So this function is also neither odd nor even. And again, if you make a function up off the top of your head, just kind of throw something together, chances are it's not going to be odd and it's not going to be even. That is the most common situation. In fact, symmetry of any kind is rare and special, and when we have it, we make a big deal out of it. Okay, so before I finish up this lesson, I want to leave you with a little bit of a cautionary statement. I'm not going to say a lot about it. If it's something that kind of raises questions or piques your curiosity, feel free to start a discussion session about it, and I'm happy to talk further with you. But I just want to say one thing in my caution box here at the bottom. If f of -1 is equal to f of 1, that's not sufficient to call the function even. Okay, so if you want to show that a function is even, it's not enough for one value of x, for f of 1 to be the same as f of -1. If you want to show that a function is even, it has to be true for all values of x in the domain of the function. So again, this might be something that you're like, wait a minute, how come? But here are some examples where. And that's something we can absolutely discuss further. I'm not going to say any more about it in this lesson. It's something I want you to noodle on, and feel free to start a discussion session and we'll answer more questions. All right, so this is the last of a 3-lesson series on symmetry. I hope watching it has been handy, and watch for more videos as I create more video lessons. See you soon.